So in this video, we're going to talk about how to solve exponential equations. So a negative exponent indicates a reciprocal. So if you have a to the negative n, that's going to be represented as 1 over a to the n. If you have 1 over a to the negative n, that is going to be a to the n. So I like to kind of think about a negative exponent as like it's flagging you, okay? It's telling you that it's in the wrong place. So if you move it to the other side of the fraction, then it becomes a positive exponent. So for example, if we have x to the negative 3, you may be wondering, well, this doesn't even look like a fraction. Remember that anytime we have a whole number, we can put it over 1. So that x to the negative 3, if I move it to the other side of the fraction, I can have 1 over x to the third. Okay, so then that becomes a positive exponent. So if I have 1 over x to the negative fifth, I can move this from the denominator to the numerator, and that becomes x to the fifth over 1, which you remember I can just write that as x to the fifth. Okay, so kind of think about a negative exponent as being in the wrong place. So let's rewrite 2x to the negative 1 over 3 to the negative fifth using positive exponents. So what I'm going to do is I'm going to go to this fraction. I'm going to take anything that's a negative exponent and move it to the other side of the fraction. So the x to the negative 1 is going to come down here. So I have x to the 1. And the 3 to the negative fifth is going to go up here. So I have 3 to the fifth. So this is just going to become 2 times 3 to the fifth. And 3 to the fifth I'm going to do on my calculator. That is 243. And that is over x to the 1. Well, x to the 1 is just x. So 2 times 243 is going to be 486. So we have 486 over x as our final answer. So now you can pause the video and try this example on your own. So let's rewrite 4 to the negative 2 over xy to the negative 6 using positive exponents. So I'm going to move the 4 to the negative 2 to the denominator and the y to the negative 6 to the numerator. So when I do that, I get y to the 6th over x and then times 4 squared. 4 squared is 16, so when I rewrite this, I get y to the 6th over 16x. So an exponential equation is an equation that contains a variable in the exponent. So for example, when we have y equals 4 to the x, that is an exponential equation. So let's classify these equations as linear, quadratic, or exponential. So in y equals 2x, remember the x is to the first power, so that is going to be a linear equation. If we have y equals x squared, that's the second power, so that's going to be a quadratic equation. So here we have y equals 2 to the x. Notice that the x is in the exponent, so that is going to be an exponential equation. So when we have exponential equations, we have this property of equality that we use to solve these equations. So if a is a positive number other than 1, then a to the x equals a to the y, if and only if x equals y. Okay, so notice here what's going on is that the bases have to be the same. Okay, so if the bases are the same, then the exponents can be set equal to each other. So for example, if we have 3 to the x equals 3 to the 2x minus 5, notice that the bases are the same in both of these expressions. So what we can do is we can go ahead and set these two exponents equal to each other. So when we do that, we end up getting x equals 2x minus 5, right? Because we have the same base, which is 3. So now we just need to solve this equation. So to solve this equation, we need to work on getting all the variables on one side. So since this is a 2x, I'm going to do the opposite and I'm going to subtract 2x from both sides. So when I subtract 2x from both sides, on the left side, that's a 1x minus 2x. So that is going to be 1 minus 2, which is negative 1, right? So that's going to give me a negative 1x equals 2x and minus 2x cancel, and that's negative 5. Now we need to divide both sides by negative 1, and so we have x equals negative 5 over negative 1, which is positive 5. So remember, you always want to check your solutions by plugging back into the original equation. So that gives us 3 to the 5th equals 3 to the 2 times 5 minus 5. So when we simplify this, we get 3 to the 5th equals 3 to the 10 minus 5. So that tells us that 3 to the 5th equals 3 to the 5th. So x equals 5 is the valid solution to this problem. So when solving exponential equations, sometimes you have to rewrite the problem so that the bases are the same. So when you're doing this, there's a squares chart and powers chart that I put together with the commonly used squares and the commonly used powers in these problems. So you can download it, you can print it off, save it to your computer, whatever you need, and it can be very helpful when you're doing these problems. So the first page has the squares from 2 to 29, which are the most commonly used ones. And then the next page has the commonly used powers, which lists out the common powers from 2 through 10. So, you can use this and it's kind of use it as a reference guide when you're working on these problems. So also remember the power of a power property. So when you're working with exponents, if you have a term with an exponent that's raised to another exponent, you end up multiplying the two exponents together. Okay, so a to the m raised to the n power is a to the m times n. So when you're solving exponential equations, this is going to be our strategy. Okay, you're going to start off rewriting the problem so that the bases are the same. Use the squares and powers chart to help with this. Then simplify the power of a power by multiplying the exponents. And then once the bases are the same, you're going to set the exponents equal to each other and solve for the variable. So let's look at this example. So we have 3 to the 4y plus 2 equals 27 to the 2y minus 1. So what we need to do is first figure out how we're going to rewrite this problem so that we can get the bases equal to each other, okay? So what you want to do is kind of look at that powers chart and see where we have a base that can be written the same way. So on the left side, we have 3 to the 4y plus 2. And if we look at our powers chart, notice in the powers of 3, we have 3 to the third equals 27. Okay, so we can rewrite this as 3 to the 4y plus 2 equals 27, which is 3 to the third, and that's raised to the 2y minus 1 power. Okay, so now we have this rewritten, but what we need to do is we need to simplify that exponent. Okay, so we have a to the m raised to the n power, so that equals a to the m times n. So what I'm going to do is I'm going to take that exponent on the right and I'm going to multiply those two exponents together. Okay, so when I do that, that 3 is going to distribute, so I have 6y minus 3. So this is going to become 3 to the 4y plus 2 equals 3 to the 6y minus 3. So now what I need to do is set those two exponents equal to each other, right? Now I can do that because I have the same exact base on both sides of the equation. So when I set those two exponents equal to each other, I need to now solve for y. So notice on the right I have a 6y, right? It's a positive 6y, so I'm going to do the opposite. I'm going to subtract 6y from both sides. So when I do that, I get negative 2y plus 2 equals 6y and minus 6y cancel, and that equals negative 3. And then I'm going to subtract 2 from both sides. And when I do that, I get negative 2y equals negative 5. So when I have negative 2y equals negative 5, I'm going to divide both sides by negative 2. And so we get y equals negative 5 over negative 2, so that's y equals 5 over 2. So now we need to substitute that 5 over 2 back into our original equation and make sure that it works. So we have 3 to the 4 times 5 over 2 plus 2 equals 27 to the 2 times 5 over 2 minus 1. So when we do that, we get 3 to the 4 times 5 over 2, so that's going to be 10 plus 2 equals 27 to the 2 times 5 over 2, so we have 5 minus 1. So this tells us that 3 to the 12th equals 27 to the 4th, and I am going to use my calculator to figure out the rest of this problem. So 3 to the 12th, I get 531,441, and then 27 to the 4th does in fact give me the same number, 531,441, okay? So this checks out, so y equals 5 over 2 is the solution to our problem. So now let's go ahead and solve this equation. We have 16 to the 3x equals 64 to the x minus 2. So once again, you want to glance around that powers chart and see which part of that chart has like a 16 and a 64. If we look at the powers of 4, notice that 4 squared is 16 and 4 cubed is 64. So if I rewrite these both as powers of 4, I'm going to have the same base on both sides. Okay, so that's kind of my strategy here. So I'm going to rewrite that 16 as 4 squared. Okay, so I have 4 squared to the 3x power. And that 64, I'm going to rewrite it as 4 cubed. So I have 4 cubed to the x minus 2 power. Okay, so now I'm going to use that power property, right? That a to the m to the n equals a to the m times n. And so I have 2 times 3x is going to be 6x. And that is going to be on the right side. I have 4, and then I have 3 times x minus 2. Okay, so I'm going to distribute that 3. So that gives me 3x minus 6. So I have 4 to the 3x minus 6. Okay, so now what I'm going to do is I have the same base. So I'm going to set the exponents equal to each other. So I have 6x equals 3x minus 6. This is a positive 3x, so I'm going to subtract 3x from both sides, which gives me 3x equals negative 6. And then if I divide both sides by 3, that gives me x equals negative 2. Okay, so you always want to make sure that your solution works. And so we do 16 to the 3 times negative 2 equals 64 to the negative 2 minus 2. Okay, so that's 16 to the negative 6 equals 64 to the negative 4. So if we do 16 to the negative 6 power, that tells me I have like 5.96 times 10 to the negative 8. This is just what my calculator is telling me. And I have 64 to the negative 4th, which is also 5.96 times 10 to the negative 8. Okay, so that checks out. So that means that x equals negative 2 is my solution. So now you can go ahead and pause the video and try this example on your own. So once again, you're going to look around that powers chart and see where you have an 8 and 2 kind of related to each other. And that is in the part where you have the powers of 2. Okay, so 8 can be rewritten as 2 to the third. So we have 1 over 2 to the third to the x power. And that equals 2 to the 3x plus 2. So remember, when we have that, we can write that as a reciprocal, right? So that 1 over 2 to the third can be 2 to the negative 3. So we have 2 to the negative 3 to the x power. So that tells me that 2 to the negative 3x equals 2 to the 3x plus 2. So when we set those two exponents equal to each other and solve, we have negative 3x equals 3x plus 2. And if we subtract 3x from both sides, we get negative 6x equals 2. And then we divide both sides by negative 6, and it gives us x equals negative 1/3. So if we plug it into our equation, we have 1 over 8 to the negative 1/3 equals 2 to the 3 times negative 1/3 plus 2 power. Okay, so we have 1/8 to the negative 1/3, and that equals 2 to the 3 times negative 1/3 is going to be negative 1 plus 2. And so this we can write as a reciprocal, right? We can actually say this is 8 to the 1/3 equals 2 to the 1, and that does work out. 8 to the 1/3 is just actually the cubed root of 8. So this tells me that the cubed root of 8 equals 2, which is in fact true. Okay, so x equals negative 1/3 is the solution to this problem. So remember, you can solve exponential equations using the property of equality if a to the x equals a to the y, if and only if x equals y. So to use this property, remember the bases must be the same. So you have to use the powers chart to change the values in the equation so that the bases become the same.